Welcome back to the my YouTube channel FFVMD, where everything is G9, but name is fact, but everything is G9. Circular motion, centripetal acceleration. When body moves on a circular path of radius r with uniform speed, an acceleration start acting toward the center is called centripetal acceleration. And it is given by AC equals to V square by R, where V is the speed of particle on circular path and R is the radius of circular path. It is also called radial acceleration. Centripetal force. The force acting toward the center in a circular motion is called centripetal force. It is given by Fc equals to m into V square by R. Motion of a car on a level road, circular. A car is moving on the circular path. Here, the necessary centripetal force is provided by the frictional force between the road and the tire. The free body diagram of car is shown. The normal force is acting vertically upward direction and the weight is in downward direction, and frictional force is acting along the center of the circular path. When we apply sigma Fy equals to 0. This gives n minus mg equals to 0 or n equals to mg, equation 1. Now for x direction, sigma fx equals to ma. This implies here fx, we have only one force, frictional force. So we have F equals to m into AC equals to mv square by r, equation 2. So for shape turning, F must be less than equal to Fs max. This implies mv square by r must be less than equal to Fs max from 2. This implies mv square by r is less than equal to mu s into n. This implies mv square by r is less than equal to mu s into mg. Or this implies v square by r is less than equal to mu s into g, or v square less than equal to mu s into rg, or v less than equal to under root mu s into rg. Hence v max equals to under root mu s into rg for safe turning. That is, this velocity shows the maximum velocity of a car that can go on a circular path. Now motion of a car on a banked road. A में centripetal force is provided only by banking of road, component of n. Here the situation is shown. The free body diagram is shown because n is acting in along this direction, but the car weight is acting along this direction mg, and the road is banked at angle theta. Now taking the component of n, the n will be in this direction n cos theta, and in this direction is n sin theta and mg. Now because in car is not moving in upward direction, so in this direction net force is equal to 0. So we apply sigma Fy equal to 0. This gives n cos theta equals to mg. Again for x direction, that is direction along center, sigma fx equals to ma, or equals to, because in central direction the force is acting n sin theta, so n sin theta must be equal to mass into acceleration, and in the central direction that acceleration is centripetal acceleration. So we have written m into AC equals to m into v square by r, equation 2. Now divide 2 by 1 gives tan theta equals to mv square by r into 1 by mg v square by rg. This implies v square equals to rg tan theta equals to v equals to root rg tan theta. That this velocity gives the velocity of car moving on the inclined circular path safely with safety. Now motion of a car on a banked road when force is also frictional force is also acting. Here the free body diagram of car is shown. The normal force is acting in this direction. It has two components, one in vertical upward direction n cos theta, and another is in this direction n sin theta. Also, frictional force is acting in this direction. So frictional force have also two components, one in this direction and another in this direction. So if there is a limiting friction force or a kinetic friction force, we can write FL in this direction, FL cos theta, and in this direction FL sin theta. Now we have sigma Fy equals to 0 because there is no motion in the vertically upward direction. This gives us n cos theta minus mg minus FL into sin theta equals to 0, or this implies n cos theta equals to mg plus FL sin theta, or equals to mg plus mu s into n sin theta, because FL equals to mu s into n, since FL equals to mu s into n. Or n into under bracket cos theta minus mu s sin theta equals to mg. Hence n equals to mg by cos theta minus mu s sin theta, equation 1. Now for central direction, we can write sigma fx equals to m into ax equals to m into v square by r. Now in central direction, the component of frictional force is FL cos theta and the component of normal reaction is n sin theta. So FL cos theta plus n sin theta equals to mv square by r. Mu s into n cos theta plus n sin theta equals to mv square by r. Or r into n by m into mu s cos theta plus sin theta equals to v square by r. Hence v square equals to r by m into mg by cos theta minus mu cos theta into mu s cos theta plus sin theta, which gives v square equals to rg into under bracket mu s cos theta plus sin theta divided by under bracket cos theta minus mu s sin theta. So we have v equals to under root rg into under bracket mu s cos theta plus sin theta divided by under bracket cos theta minus mu s sin theta. Now dividing upper term and lower term with cos theta, we get under root rg into mu s plus tan theta divided by 1 minus mu s tan theta, equation. This is the maximum speed of the car on a banked road. Now if we take mu s is equal to 0, that is frictional force is not acting on the car, then we have v equals to under root rg tan theta is called the optimal speed and is denoted by v0. So optimal speed v0 equals to root rg tan theta. At this speed, frictional force is not needed to provide centripetal force. The component of normal reaction is enough to provide the needed centripetal force. Answer.